Hi guys! Sorry I am not with you today. My poor kiddo is sick and you're going to hear him coughing in the background. So let's see what we can do here. Alright, so section 11.1 is review just like your homework. It's solving systems with 2 or 3 variables. And the idea behind this is to find solutions. So to find an x and a y that's going to make both equations true. So in what are we looking for? We are looking for an x value. And there he is, and a y value that work in both equations, or that make both equations true. I know, buddy, they're going to be on in a minute. That make both equations true. Okay, and then what does it look like graphically? If you have an x and a y value that make both equations true, ultimately you have an intersection point. So it's the point where these 2 equations intersect on the graph. Now, for example, if you had a quadratic and a linear function, you might have 2 intersection points. For now, we're just going to look linear. So if I am talking graphically and you have one solution, we call these consistent independent systems. So if you have one solution, you guys have this on your notes already, but I wanted to write it in a different color. It's called consistent because a solution exists. Solution exists. And it's independent because it's one solution. Okay, so that's the difference. So independent because there's one solution. What does that look like on a graph? If I had 2 lines, and then lo and behold, ta-da, they intersect at one point. Okay, there's one intersection point. Now, if you have infinite solutions, you are consistent because a solution exists, but you are dependent because there's infinitely many. And the way that I like to think about that is, well, I'll show it to you first. If you have infinite solutions, and I'm going to have to use a different color so you can see this, you are ultimately the exact same line. Yikes. Okay, so I think of it as dependent because you're dependent on one another. You are the same line, and there are infinitely many solutions. Okay, if there's no solution, you are simply inconsistent because a solution and intersection point does not exist. So ideas on what this could look like? Ah, you guys are so smart. Good job. Parallel lines. They will never meet. Wah, wah. So sad. Okay, so 3 different solutions for linear systems. Now, you guys had your homework on this. I will post the answers for it on Canvas. Sorry, it's shaky. So make sure that you check it. I'm going to do both methods in case you looked at it and were like, what the heck is she doing or expecting me to do? Okay, so the first one I'm going to do is substitution. And usually I find students have a favorite. Systems will lend themselves to one or the other depending on. So the idea behind substitution is that you want to isolate a variable. So in the top equation, I'm going to isolate y. So I have negative 2y is equal to negative 3x plus 0. The 0 isn't necessary, of course. And then I'm going to divide by a negative 2. So y is equal to 3/2 x. Okay, once you isolate the variable, you then go to the second equation and substitute it in. Okay, we know that y is equivalent to 3/2 x, so I'm going to say that 5x plus 10 times 3/2 x, because I'm just substituting in for y, is equal to 4. Hopefully you guys are like, yeah. If not, you're welcome for this fantastic review. So then we have plus, these 2 can reduce. 15x is equal to 4. We have common terms on the left. I'm going to combine them. So we get 20x is equal to 4. So x is equal to 1/5. But you're not done because remember up here, we're looking for the intersection point. So I'm going to take the 1/5 and I'm going to substitute it back into the first or the second equation, or even the y equals 3/2 x. So in substituting it in, 3/2 times 1/5, I get 3/10. Make sure, since you are finding an intersection point, that you write it as such. X comma y. Yay! Okay, so the second one that we're going to look at, I've already used purple. Let's use pink, is elimination. Okay, again, the systems, poor kiddo, the systems will lend themselves to one easier than the other. Sorry, I'm not happy with the pink. We're going to go with the blue. So you need to not only find coefficients that are the same number, but they have to be opposite signs, because when you add them together, what do? Eliminate. So I'm going to take the first equation, which is 3x minus 2y is equal to 0, and I'm going to multiply it by 5, because I see right away that my y's have opposite signs. Okay, so we get 15x minus 10y is equal to 0, and then below it I'm going to write the other equation, 5x plus 10y is equal to 4. Add them together, I get 20x is equal to 4, and what? X is 1/5. Exactly what we got over here, and that's great. I then need to pick, now I only have two options here. I have one or two. I mean, I suppose you could use the bigger equation with the bigger coefficients. It's, again, up to you. I'm going to go back to the original, so 3x, so 3 times 1/5, minus 2y is equal to 0. I get 3/5 minus 2y is equal to 0. Negative 2y is equal to negative 3/5. Multiply by the reciprocal. Those go away, and y is 3/10. Don't forget to write it as a what? Oh, yes. As a coordinate. Fantastic. Okay, so super fast review. If you fast forwarded through it, I'm not offended, because you may be like, yeah, this is total common sense. If not, again, you're welcome. All right, guys, so solving systems. This is where it might be a little bit new for you. My suggestion always with these is you need to number them, because it's going to get a little hairy. You need to know what you've used and what you haven't used. So I'm going to label them equations 1, 2, and 3. Okay, once you've done that, you need to eliminate a variable twice. Okay, so ultimately I have some options. I could do x, y, z. I see that z has a negative, and then I have two other positives, so that's going to give me a lot of options. I will choose to eliminate z. Okay, I'm going to take equation 1, and I'm going to add it to equation 2. So I need to multiply that by 2. That's going to give me, make sure you distribute the 2 to every single term. That's going to give me 4x minus 6y minus 2z is equal to 0. And I'm going to add it to the second equation. Really important you write down the numbers, because you don't want to duplicate, and you'll see what I mean in a second. So 3x plus 2y plus 2z is equal to 2. Okay, we're using elimination. That's how I teach it. You're more than welcome to use substitution. I have just found in the past for myself and my students that elimination is a lot cleaner. Okay, when I add it, the z's go away. I get 7x minus 4y is equal to 2. This becomes equation number 5.